Hi, hello. I'm Adrien Delorme, and I'm a software engineer at HashiCorp on the Packer team. Today I'm going to show you how HCL makes the Packer experience way better. So first I'm going to describe Packer a little, then I'm going to explain to you why moving to HCL 2 and what makes it like a good choice and what it looks like, for example. And then finally, I'm going to give you a glimpse of what is the future going to look like with Packer. So HCL, or the HashiCorp configuration language, is an open source library maintained and made by HashiCorp. HCL is pretty interesting as it is a language oriented towards configuration. A good example of that are the dynamic blocks and the for each blocks that can generate new configuration contents from variables. Fun fact, in one of my interviews before joining the Packer team, I remember asking what would be a big challenge I could work on. And one clear answer was HCL, that's going to be it. And I remember thinking to myself, easy, I'll just swap the library and be done. Well, it turns out it was a bit more complex than that. But first, let me talk about Packer a little. Packer is an open source tool for creating identical machine images for multiple platforms from a single source configuration. It helps you automate your machine image building, whether you want your image on AWS, GCP, Docker, a private cloud, for example, or QEMU. For example, if you have to build a base server image from an Ubuntu server ISO, and it should have your security and telemetry settings, you could use Packer to start an instance, apply your security and telemetry provisioning steps, and then save it. And that is going to work for many environments. And then from that base image, you can make the blocks that constitute your cloud. So if, for example, you have programs that work in clusters like this, you could save the common cluster settings of a Kubernetes image and then start them, link them in the network, and then you have a cluster. It's probably a bit more complex than that, but yeah, that's another topic. You could also put your app in the image, and that's up to you. Packer has 34 core builders integrated in its code. Each builder gives the ability to build machine images somewhere, like in the cloud, VM, Docker, QEMU again. Packer has 18 provisioners, and they allow you to apply changes to an image. So, for example, you could use the shell provisioner to run shell commands onto a running builder, or you could use the file provisioner to upload or download something from a running instance. Post-processors are optional, and they allow you to reuse or use the result of a build. So you could upload a Docker image or an AMI somewhere, or a VMware image somewhere, extract just the files you need, or create what we call a manifest file that is like a list of the things you've built in Packer. Builders, provisioners, and post-processors are interacting with Packer as if they were external plugins. We call them plugins or components of Packer. In the Packer team, we are 4 core maintainers. Yeah, that's not too much. We are working from pretty much around the globe. We have Oregon, Florida, Germany, and I'm in the Netherlands. This gives us a lot of time zone coverage, but we do have weekly meetings to stay in touch though, because we don't have a full Earth day overlap. So for example, in Europe, it's the beginning of the day, and then we get Florida around noon, and then late in the day, Oregon comes in. Currently, Packer has 1,088 persons that have contributed to either the code, the documentation, or the example, and they're from all around the globe. We try our best to help everyone, and as always, peers are welcome. So if you want to contribute, we try to be as welcoming as possible. Why HCL 2? Yeah, good question. So yeah, JSON works with Packer, but Packer has been known to only work with JSON. And here's an example. There are quotes everywhere, and it can make it a bit hard to parse the text as a human. HCL 2 has much less quotes, and it uses quotes only when you want to set strings, so not fields, making the parsing a little bit easier on the eyes. Variables are kind of quirky in JSON and not enough. So there can only be string variables, no arrays or objects or lists, and If a variable is null, like on the top example, then it's mandatory to be set when you start Packer. But then if it's the empty string, like the second line, the third line, then it's optional. There is no variable validation in Packer, so things are validated at runtime by builders and provisioners. Everything is read once with JSON, and that's like how the JSON library is done. And like here, for example, that AWS access key user variable setting is not known as at the time we start that builder. So that builder has to start, then fetch what the value of this variable, and then update itself with the value that we know they have. In more advanced cases, this is run twice. So yeah, JSON is making it also very hard to factor out all the common fields and the login information from the builder. So each builder has manual setup for credential and something that I think would be less repetitive. And so in HCL2, you can programmatically define in which order blocks are parsed, making it easy to know values before actually evaluating a block. So, for example, the builders or the components would not have to like interpolate the variable values. This will also take that burden out from components while simplifying components and making Packer more powerful at the same time. Generally, I think that the user experience of Packer JSON could be a little bit better. Config files are a bit hard to understand at first sight, and it can be a little bit of a scary thing to look at as a newcomer. There is so much config repetition, for example. So if you are building similar images like this one and want to change only one field, so for example, if you have an Ubuntu server that is an Ubuntu server building block and you want to build just a different version of Ubuntu, then you have to copy all of the content of that builder and then just change that field. You can make variables, but the body is still going to be a huge chunk of body. And in HCL, we've tried to make that much more simple and like less repetitive. Speaking of user experience, remember, let's say you have a base server image from which you want to build downstream images like this. Build chaining in Packer JSON is super hard currently, and the only way to do this is to create a manifest file, a JSON manifest file, parse it, and run Packer again. Here's an example of how you would get your base server image. So here we have three builders, an Amazon EBS, a Docker, and a QEMU builder, to which we apply security and telemetry scripts settings. And finally, we use the manifest post-processor to ask Packer to tell us, hey, what was built? And Packer creates for us this JSON file. This is a simplified version of it. And note that the order of these entries is not predictable since Packer is run in parallel, so you can have a build that runs first, and then you cannot just say, hey, give me the first value of this, and I know it's going to be Docker. If you'd want to reuse that, all you have to do is that giant JQ command. From there, you could use the output from that command as a var file parameter and give it back to Packer in the next build. That works, but this feels like not good enough because you have to get out of Packer to do this and then install a JQ, which is a third dependency, a third-party dependency. And I was thinking that maybe Packer could do all of that. HCL2 allows to have blocks that depends on other blocks. So in theory, it's going to be easy to have like a building block that depends on another building block. And then the second one would wait for the first to be done before starting your builds. And then with a little states added to that, we could do build chaining pretty much more easily. This is still a to-do for Packer though. YAML was not really an option, since it's pretty much the same as JSON, but without the curly brackets and not as many quotes. It's a little bit more dangerous in my opinion, as NO, for example, without the quotes will be interpreted as the false boolean, for example. So if you are interacting with Norway and the country code of Norway could be NO, then suddenly you have a country that is false, and that could, for example, take down a cluster or something. But you can write comments though, that's nice. YAML is also single parse, so we would have to do the same tricks that are preventing us from building on top of, that are preventing us from making Packer better. HCL1 was not an option as well. We have tried to go through the HCL1 route, thinking it would be just a step to upgrade to V2. but it turns out that the library drastically changes for the better between the two versions. And it was just easier to go directly to V2 from JSON. So yeah, HCL1 is great, but HCL2 is the result of a lot of usage and improvements and trial and error upon HCL version 1, which had some flaws. Okay, let's see some HCL on Packer now. This is an example of an HCL2 config file. Check out these comments. This is roughly the same Amazon EBS config as I showed you before, but in HCL. Yeah, the fields you can set are pretty much have a one-on-one match with the one you can set in JSON. So yeah, all the fields you're used to using JSON will be settable, but in HCL2. This is because the code that reads HCL2 is code generated from the code that reads the JSON, and that allowed us to be much faster and like safe to go to HCL2. Packer didn't have to change too much to bring HCL, but a few things did change. The main blocks of Packer, builder, provisioner, post-processor, and variable are present, but presented in a slightly different manner. They're called in HCL blocks, and their type and name will be at the label at the top, and instead of being inside the block, which I think makes them easier to like read and parse. Here's a side-by-side example of a variable definition. So in HCL, pretty much like for Terraform, you name the variable from the label at the top. You can give a variable a type and a default. Here, because that variable has a default, is a default string, then its type will be also a string. So everything you want to give to foo has to be transformable to a string. A builder becomes a source, but here this source statement you see on the right will not start anything. That source block simply defines your builder settings as like an importable build block. And to reuse that configuration somewhere else, it's like a bag of fields, and you can call it from a build. So to start a builder, you have to invoke a source from a build. So in that example, you can see we have started two sources, and one is a simple call, and the second one, the singular source, is specifying just one field to be different. And that gives us a lot of power to not repeat ourselves, because the first source definition could be like more generic, and then we could specify the specific fields we need. And that made Packer build files much cleaner. Now, to run a provisioner and a post-processor on those builds, all you have to do is create a provisioner and post-processor blocks. Again, their type is at the top in double quotes in purple, like you can see here. And all the fields you're used to set, except the type field, will be settable in HCL. If you want to give Packer HCL2 a try, there is an HCL2 upgrade command that will transform your JSON file into an HCL2 file. It's quite handy because you can just give it a try. Another cool thing about HCL2 blocks is that you can now split your config files into multiple files. Here's an example. Here you can see we have multiple files, and you can now run Packer builds on the folder. You can also see that we have defined new extension types. HCL is tool specific, therefore an editor and a tool cannot just interpret the HCL for Terraform, Consul, or Packer the same way. And in order to make it easier for tools to differentiate them, Packer will only be able to see .pkr.hcl files. Those files are where you define your HCL blocks and configs. There are also pkr.vars.hcl files, and they're a bit similar to what tev.var files are. So here you can set the values of already defined input variables. So in this file, Packer only expects values of input variable to be set. Also, we expect those variables to exist, so to be defined in a .pkr.hcl file. HCL2 also supports JSON. So with the same structure as HCL2 sources and with the same capabilities. But be careful though, because classical JSON is not HCL JSON. Here's an example. These two configs are doing the same thing, but the one on the right-hand side is in JSON. We recommend always sort of avoiding HCL JSON if you can. And if you like a good example of a good use case for HCL JSON would be if you wanted to auto-generate parts of your configs and you have a missing feature and you want to generate parts of your config. Packer HCL2 has some caveats right now. HCL2 support is currently beta. It has been beta since we released the first version of Packer back in December 2019. It has improved a lot since. By the way, many thanks to people testing, submitting bug reports, feature requests, and code to Packer. You have helped us a lot. Thanks. Some parts of Packer HCL2 still depend on the Go interpolation. Here's an example. So here you can see the Go interpolated variables are not the same as the HCL interpolated variables, and they are interpolated at different times. So here in that example, that's going to work. So that HTTP server is going to serve these preset files pretty okay. But here in that example, the double quoted string in red is a template call, a Go templating call. Because HCL2 runs first, that call is going to be uppercased, just like the example at the bottom. And when the Go templating will run, then that's going to be an error. Again, this is avoidable if you make your call 100% HCL. And a reminder, Packer HCL has a great set of functions, and they are very similar to the Terraform functions. And I recommend on trying those if you can't. Yeah. And I also recommend being 100% HCL if you can. Packer HCL2 has stabilized recently, and we, the Packer team, have started to feel much more comfortable using Packer HCL2 because it feels so much better. The templates are much smaller. You can reuse variables, and then it's so easier on the eyes. But yeah, as I said, Packer HCL2 is also giving us a lot of opportunities to improve on other things. But first, we would like to sort of reach parity with the current Packer JSON version. And when we are there, we will slowly start deprecating JSON and slowly start adding new features to the HCL version. And here are a few things you would love to do when we can. Currently, Packer HCL2 cannot chain builds. So if you have to split builds into multiple post steps, then you will have to do the same as before. And in the future, we would like to add a stanza to make, for example, a source block or a build block dependent on another build block. And then you can have a build that builds your base image, and then your delta image will be built later on without needing to go out of Packer. Terraform interoperability would be awesome, wouldn't it? It would be nice, like if you could reuse the result of a Packer build into Terraform to, say, start an instance. The solution would check if the image exists, for example, and run Packer if need be. Then we would like to completely get rid of Go templating, but it's going to be a slow deprecation process. In Packer, everything is a plugin, like I said before, but currently all plugins are inside the GitHub of Packer. All plugins are inside the code base. And we recently started denying new plugin contributions to the Packer core because, like I showed you in the beginning, we have a lot of plugins to maintain, and it's starting to get very hard for people. But we would still love to help you create plugins for Packer. And currently, adding a plugin to Packer as a user is kind of hard. You have to put it in the right place, and you cannot tell Packer to download it. And we would like to add a new stanza in HCL that allows to download a plugin, put it in the right place, so you don't have to do that manually, and then your build could be more automatic. We will know a bit more about this a bit later this year. Thanks. As always, pull requests are welcome, issues are welcome. Don't hesitate to ping us if you have any questions. And yeah, I think I'm done.